49 from 10.2, and we just had to do A, B, and C. D got a little crazy. Okay, the object is moving along the curve in the xy plane, has position vector x of t, y of t at t greater than 0, with x dt equal to 2 plus the sine of t squared. The derivative dy dt is not explicitly given. That means you could kind of figure it out, but it's a chore, so we won't do that. At time t equals 2, the object is at the position 3, 5. First of all, find the x-coordinate of the position of the object at t equals 4. All right? Now this is funny because the answer in the book wasn't right, so you just have to check this. So if you looked in the back of the book and you didn't get the right answer, then hopefully you're coming here, because I don't know what they were thinking when they did this one. All right, so the position at t equals 4 is going to be equal to the initial position. That's the position at t equals 2, plus the displacement from 2 to 4. And we've done this before using just particle motion. All right, so my position at 2, I know the position is 3, 5 at t equals 2, so x of 2 equals 3, y of 2 equals 5. So I know x of 2, that's going to be 3, and then I have to find the displacement from 2 to 4 of v1 of t, and I do have the v1, that's this guy here. So that's going to be the integral from 2 to 4 of 2 sine of t squared dt. And we don't have enough to take the antiderivative of this because we need a 2t to do a u substitution. We don't have a t, so we're stuck, so we're going to have to use this with our calculator. All right? So we know that x of 2 is 3, and if we put this in your calculator, you're going to get 3.942. Well, that's the answer they had in the book, but they didn't add the 3 to that, so it should be, or my position at t equals 4 would be 6.942. So they needed to do that. I don't know why they didn't add that. Makes no sense to me, but they didn't. But that's what you have. All right? Okay, letter B. At t equals 2, they tell you that dy dt is negative 6. We still have our initial position or our given points. So what they want you to find is write an equation for the line tangent of the curve at the point 2, 2. X sub 2, y sub 2. So x sub 2, y sub 2, this would be the point, 3, 5. We know we're given that right up here. So now we need the slope. Well, the slope is going to be dy dx at t equals 2. Well, they gave us dy dt just at 2. So that's going to be dy dt over dx dt at 2. And they gave us this at 2. And at 2, we just put this in dx dt. They gave that to us explicitly. So I put 2 in there. 2 squared is 4. So there's my slope. So I got my slope at t equals 2. I've got my points. So I just use the point slope form. Y minus y1 equals m times x minus x1. Y minus 5. Oops, that should be y minus 5 equals my slope, negative 6 over 2 plus sine 4 times x minus x1. And there you go. So that's what you got. And letter C, find the speed of the object at time t equals 2. Well, we can find the speed at t equals 2 because we've got this data here. So that's going to be equal to the absolute value of the velocity curve at t equals 2. So that's going to be the derivative of the position of the horizontal component squared plus the vertical component squared. So this is going to be 2 plus the sine of 4 squared. I figured that out on my calculator to be 1.5455. And negative 6 squared is 36, so I could add those up. And I get 37.5455, and I take the square root of that, and 6.127. So, nothing too difficult. Just have to keep track of these things and watch the notation. Go through these, master these problems, and you've got a whole bunch down.